أهلا أصدقائي. اليوم راح نتكلم عن another hands-on. It's about immunity debugger. Okay, first of all فيه four areas. 1 2 3 4. This area is called code area, and this area is called registers area, and this area is called memory area, and this one here is stack area. Okay, to see it clear, more clear, we need to open exe file or application based on 32-bit system. So we're gonna go to C program files x86 and choose any exe program to show. For my case, I chose this program. Okay, gonna open that. You can open any program in program files, which is 32-bit system. Okay, as you can see now, this is the code area, again registers area, memory area, stack area. Okay, there are lots of codes here and symbols. We're gonna talk about them one by one. Okay, I put them in a notepad here. Okay, for the AX, it's the primary accumulator. Okay, it's used in input, output, and most arithmetic instruction. We're gonna see it in the immunity debugger. AX. Let's find AX. Here is AX. Okay. The next one is BX. We can find it here, somewhere here. It should be some, yeah, here we go. BX. Okay. Next is CX. By the way, BX is base register. CX is count register. Okay, CX. We can find CX somewhere here. Okay, CX. And the next one is DX, which is data register. Okay, DX. We have it here, I guess. Yeah, DX. Okay. And we have also the pointer registers. IP. Let's find the pointer register. IP. Here we go. IP. It's called sorry, instruction pointer. IP instruction pointer. Okay. And the next one is the stack pointer. SP. Okay, SP. And for SP, let's find it in the stack, since it's a stack pointer. We have the stack area here, so let's find it in the stack area. SP. Let's look for 0019FF78. 0019 FF78. Where is 78? Okay, do you see any 78 here? Okay, yeah, here we go. See, the stack pointer pointing to the stack here, and it says return to kernel 32. Okay, and the next one is the base pointer. Where is the base pointer? B, BP, BP. Okay, here we have base pointer. Okay, so we found the stack pointer, and base pointer. Okay, we found the base pointer. Okay. Next, index registers. We have SI, which is source index, and we have DI, which is destination index. Let's see if we can find it in the register area. SI, DI. Yeah, we have SI here, and we have DI here. Okay. Okay. We also have something called control register, and this also have some meaning. We're gonna walk through them one by one. We have the overflow flag, overflow flag. We have the direction flag, and yeah, these have meanings. It indicates the overflow of a high order bit leftmost of data after signed arithmetic operation. And the direction flag, if it's 0, that means the direction from left to right. If it's 1, that means the string takes right to left direction. And we have interrupt flag. It determines whether the external interrupts like keyboard entry, etc. are to be ignored or processed. It disables the external interrupt when the value is 0 and enable it when the value is 1. Okay, we have the trap flag and sign flag and 0 flag. All these values are either 0 or 1. Okay, we're gonna find them. Sorry, auxiliary carry flag and parity flag and carry flag. So in the register it's shown as C, either C, P, A, Z, S, T, I, D, O. Okay, in the register we can see them here. Okay, it's O, D, T, S, Z, A, P, C. So we mentioned that O, what's O? It's overflow flag, and D is direction flag, and T is what was the T? The trap flag. And next is S, which is sign flag. Yeah, that's the sign flag. And this is Z, which is 0 flag, and A, which is auxiliary carry flag. that's A. Auxiliary carry flag, and P, which is parity flag, and C, which is carry flag. Okay, I think we're done with all the registers. Okay, talking about the immunity debugger, we can execute a couple of assembly instructions. If you want to do that, you can click anywhere in the code area and press the space key. You have the assembly window. You can type any instruction here, but we have to understand what this instruction means. Okay, let's try some assembly code and see the changes in stack pointer. Okay, I copied some code from the slide and we're gonna try it. First one, move EAX comma 0. What does that mean? That means we transfer the 0 here to the EAX. Okay, let's do that. Move, okay, move EAX comma 0. Let's look at the stack pointer. Okay, next code is move EBX 1. That means we transfer the 1 here to EBX. Move EBX 1. Okay, next one is move ECX2. Again, that means we transfer the 2 to ECX. Okay, ECX. Next, push EAX. That means we put EAX at the top of the stack. Now the stack pointer must change. It's FC8. Okay, push EAX. Push EAX. Push EAX. Okay, something wrong here. Okay, push EAX. Look at the stack pointer here. That must change. Okay. Did it change? I don't know. Push EAX. Stack pointer. Okay. Return to kernel. Okay. Next code is pop EBX. That means we remove the EBX from the stack. Pop EBX. EBX. Okay, we're done with that. And I cannot see any change. Anyways, that's how to. Okay, actually the working with the immunity debugger is a little bit challenging, so we need to pay more attention. And let's try another example. Okay, let's try this one. Okay, let's click somewhere here and press the space. Okay, what's the first one? Okay, copy, paste. Okay, this one gonna transfer 0 to the EAX. EAX. Okay. And let's copy this one. And this code gonna transfer 3 to EBX. To EBX. Okay, next. Inc EAX. That's gonna increment EAX by 1. So EAX gonna be incremented by 1. Okay, next. Again, it's gonna increment EAX by 1 also. Okay, next. This code. Gonna decrement EBX by 1. Okay, next code is okay, this one will add whatever in EBX to EAX. So add EBX to EAX. And the last one is this one. Sub EAX, comma 3. What does that mean is we're gonna subtract 3 from EAX. Okay, what if we have question like this in the exam? What value is entered in EAX when the command below is executed? This command. Okay, let's do it one by one. And this, after this line, EAX gonna be 0, and after this EBX gonna be 3, because we transfer the 3 in EBX. Okay, inc EAX, that means we're gonna increment EAX by 1. So EAX gonna be 1. 0 plus 1 is 1. Again, we're gonna increment EAX by 1. So EAX gonna be 2, because it was 1 and we incremented that 1 by 1, so it's 2. Okay, dec EBX, we gonna decrement EBX by 1, so EBX was 3, now it's gonna be 2. EBX equals 2. Okay, now we're gonna add whatever in EBX to EAX, so it's gonna be EAX gonna be whatever in EBX added to EAX. So we know last time EAX was 2, we're gonna add to it whatever in EBX, which is 2, that equals 4. Okay, now we're gonna subtract 3 from EAX. Now we know EAX is 4, so EAX equal 4 minus what? Minus 3. That's gonna be 1. So the value entered in EAX after this command is executed is 1. Another example and potential question in the exam is what the value is entered in EAX when the command below this one is executed. Okay, we have this command move EAX 3. That means we're gonna transfer 3 to EAX. So in this case EAX equals 3. Next is move EBX, 5. We're gonna transfer 5 to EBX. So EBX equals 5. Okay, inc EAX, we're gonna increment EAX. So EAX is 3, we're gonna increment it by 1, so it's gonna be 4. Increment EAX again, so we're gonna increment EAX by 1. It was 4, now it's gonna be 5. Compare EAX and EBX. We're gonna compare them. If they are equals, that means it's true, which is 0, so they are equal. Okay, for those who never met this command, CMP it stands for compare. Basically it's used to compare two values. If they are equals, that means when we subtract them from each other we're gonna get 0, so that means they are equal. In this case 5 minus 5 is 0. If they are equal, we execute the next instruction. So they are equal, so we're gonna execute this. If they are not equal, that means we will not get 0, then we don't execute the next command. So in this case we can execute the next command, which is jump to 80. That means we're gonna jump from here to 80, which is here, and we are not gonna execute this command. We just gonna jump there and execute this one. So since it's 0 again, that means they are equal. We're gonna execute the next one and jump to 80, because the next one says jump if it's equal, JE, jump equal 80. So we're gonna go to 80, which is this command. Okay, it says move EAX7, that means we're gonna transfer 7 to EAX. So in this case EAX equals 7. Okay, that's it. Before I end, something worth mentioning is when we move, when we use move instruction, that means we don't add or do any arithmetical instruction. We just replace whatever in EAX with 7. So 7 will replace anything here. So it was 5. Some people think we should add 7 to 5, but it doesn't. It just replace whatever there with this value. So that's how we get EAX equals 7. And that's it.